Hello everyone who are following my channel and those who are joining the all Ethiopian Universities as a freshman. Today I will continue my second section, which is about multiple choice of last year 2014 exam. So let's start our work. So the first question from the multiple choice is for a complex number z, if z times z conjugate is equal to 6, and then what's the modulus of z? What is the modulus of z? And what will be this modulus of z? So using the calculator, using a small calculation and some properties of modulus and of z, we can find that one. So what is z times z conjugate first? What's z times z conjugate? Let's take z which is equal to x plus I y. Let's consider this one. Then the conjugate of z which is equal to which is equal to a number which is reflected on the x-axis, yi, z, x minus yi is the conjugate. So what will be the product of these two? Z times z conjugate, which is equal to the product of these numbers, and which gives x square plus y square. With this calculation, we get this one. Therefore, this one is given as 16. This one is given as 60. This one is given as 60. Now, what is the definition of a modulus of z? The modulus of z is defined as this one. The modulus is a distance, is allowed. The modulus is a distance which is equal to the square root of x square, the real part square, plus the imaginary part square, which is y square. The imaginary part I square is clearly I square is which is the negative one. So I square gives this one. So the modulus of z is x square plus y square, which is equal to this one. So clearly in a complex number, we know that I square is equal to how much? This one is equal to -1. So from these two definitions, from these two results, the z times z conjugate is equal to x squared plus y squared, which is equal to 16 is given, and the modulus of z is equal to the square root of x squared plus y squared. Therefore, the modulus of z, the whole square, the modulus of z with the whole square is equal to the modulus of z is equal, or the whole square is equal to z times z conjugate. Therefore, which is equal to z times z conjugate is given this one, which is 60. Z times z conjugate is given 60. Therefore, what will be the value of the modulus? So, which implies that squaring both sides, squaring on both sides, z modulus of z, which is equal to how much? Modulus of z, which is equal to plus or minus 4, but we get, since the modulus is a distance, we get the positive. The distance is positive, so it becomes 4. So the solution for this one is B from the set of alternatives. The other one, suppose that f of x and g of x are real valued functions with f of -1 is equal to 3 and g of 3 which is equal to 2. Then what is the value of g of f of -1, which is just a composite function, composed of two functions, f and g. So clearly it's given that we are asked to find g of f of -1 at -1, g of f of at -1, which when we are calculating this one, we get which is g of is written just like this one. F of g of f of minus 1. We can write just like this one. So which is this one. So f of minus 1 is given. F of minus 1 is given 3. So we get f of minus 1 is 3. So g of, we have g of 3. And g of 3 is given, which is how much? Which is 2. Therefore, g of f of minus 1 is 2. From the set of alternatives, you can see that B is the solution. The next one is if x plus 1 is a factor of f of x is equal to k, x squared minus 2, then the value of k is dash. So factor theorem. I think you remembered about when we are learning about polynomial functions, we have seen different theorems. One of that is the factor theorem. The factor theorem said that if x plus c is the factor of the polynomial function p of x, then we can see that if it is a factor, then p of minus c, which is equal to what? P of minus c, which is equal to 0, since it's a factor of the polynomial function, the factor of the polynomial. So clearly, with the same sheet, we can say that x plus 1 is a factor of this polynomial function. Then let's find okay. So f of minus 1 is how much? F of minus 1, which is equal to 0, So which is k times minus 1 square is k times minus 1 the whole square minus 1 minus 2, which is equal to 0, which implies that minus 1 the power of 2 is 1, which is k minus 2, which is k minus 2, k minus 2, so which is equal to 0. So k is equal to 2, which is equal to 2 is the solution. So the value of k is 2. So we can see from the set of alternatives, B is also the solution for this one. The next question is, which one of the following is not true about the function, the polynomial function given x to the power of 4 plus 2x cubed plus x squared? So it's given first what is the domain of the polynomial function. The domain of a polynomial function, every polynomial function is a real number. The domain of every polynomial function is a real number. And its range is also a real number. So x to the power of 4 plus 2x cubed plus x squared is given. So let's find the roots of this equation, because most of the choices are talking about roots of the polynomial function. Therefore, to find the roots, let's factorize the polynomial function, taking x squared as common. So what's left from x to the power of 4 is, from this one, when we are taking x squared as the common factor, what's left is x squared is left, and from this x cubed, what's left is plus 2x is left, and from the last one, what's left is 1 is left from the last coefficient. Therefore, you can see that x squared, we can write this one also just like this one, so which is x squared times x squared plus 2x plus 1 is a perfect square, which is just x plus, it's just a perfect square of x plus 1, the whole square. X plus 1 times x plus 1 gives this x squared plus 2x plus 1. So which is x squared. So we can factorize just like this one. So what are the zeros? The zeros of this polynomial function are x is equal to 0 with multiplicity, with multiplicity 2, and x is equal to minus 1 x1. This is a root with multiplicity 2. So which one is true about, which one is not true about. So 0 is root of with multiplicity 2, which is true. 1 is a root with multiplicity 2, 1 is not the root. -1 is a root with multiplicity 2, and all of that. And so which one is not true? Not true is this one. B is 1 is not the root of this polynomial function. The other question is identify the statement which is true about the function, which has given an exponential function. Then to say something about this exponential function, we should draw the graph and find the domain and range of and the intercepts of the graph. So clearly we can start from the function y, which is equal to y is equal to -3 in base minus x in base 3. From this one, we can start from this one. So the graph of this function is just like this one. It's just like this one. So which is 1, 1 is the y-intercept, 1, 1 is the y-intercept, and the horizontal line y, which is equal to 0, is the horizontal asymptote, Now, with this in mind, we are asked to find, to show f of x is equal to -2 plus 3, -2 plus 3 is the power of -x. So what's -2 plus 3 is the power of x? What will we do in finding the asymptotes and the other domain and range of this function? Clearly, for this for the original function, the domain is real number and the range is 0 up to positive infinity. So what can we do? So let's start from this one. Y, which is equal to minus x in base 3, minus x in base 3, minus 2, minus x in base 3, minus 2. So when x is 0, what's y? When x is 0, y of 0, which means y of 0, which is equal to, which is 3 to the power of -0, which is 1 minus 2, 1 minus 2, which is equal to how much? Which is equal to -1. So which is called the y-intercept, So from the original function, the y-intercept was y is equal to 0. The y-intercept is y is equal to 0. Now we moved down to y is equal to 1. We moved down to y is equal to -1. Y is equal to -1. So y is equal to -1. And what is if it is y is equal to 1 is y-intercept. What y-intercept? Sorry. Y is equal to 1 is a y-intercept. Sorry, no, it's not horizontal asymptote. Y is equal to 1 is the y-intercept. Y is equal to -0, -1 is the y-intercept. Now, what is the x, the y asymptote, or the y asymptote? So to find that, as x moves to infinity, what will be the y value? When x moves to infinity, what will be the y value? So clearly, when x moves to infinity, this thing moves to 0. So y moves to where? Y moves to -2. Y moves to -2. And as x moves to negative infinity, what will be the y value? When x moves to negative infinity, this value, y value also moves to negative infinity. Y value moves to as x moves to negative infinity, y value moves to positive infinity. Y value moves to the positive infinity as x goes to negative infinity. Therefore, we have the intercept here. And we have the horizontal asymptote, y is equal to -2. We have y is equal to -2, the horizontal asymptote, y is equal to -2. So the graph of this function just looks like this one. The graph of this function looks like this one. So what will be the domain? The domain is all real number, and the range. The range of this function is negative infinity, from -2 open interval to negative infinity. -2 open interval to negative infinity is a range. And the others are, the domain is all real number. So identify which one is true for this function. Its range is 2 up to positive infinity, which is not true. Its domain is -2. Its domain is -2 up to from -2 to this one. It's not the domain. There is no x-intercept. There is an x-intercept here, which is an x-intercept. There is an x-intercept, and f of 0 is 1. F of 0 is 1. F of 0 is not 1. It's just -1. It's just -1. So the solution for this function, the truth is none of the above is true. None of the above is true statement. So this is about graph of exponential function and how to find the domain range and the intercept points of the exponential function. Which of the following is true about the function? Now we have the logarithm function here also. We have the logarithm function. Then how can we do this one? We would do similar procedure, just like what we did in the exponential function. So y, which is equal to log x plus 1 in base x plus 1 in base 2, x plus 1 in base 2, y x plus 1 in base 2, y x plus 1 in base 2. So we can write this one just like this one. Y in base 2, which is equal to x plus 1. We can write in this way. It's the same. Y, which is equal to log x plus 1 in base 2, is the same as y in base 2, which is equal to x plus 1. So we can now find the graph of this function. Now, the graph of the original function will log x in base 2. The graph of log x in base 2 is just the inverse of the exponential function x in base 2. So which is just similar to this one. It's just like this one. The graph of the logarithm function, log x in base 2. Now, the x plus 1 in the exponent, x plus 1 moves, to the horizontal to the left or to the right, horizontally, vertically from to the left, or horizontally from the to this direction or to this direction. Now let we see that. Let we see that. So when x is equal to 0, when y which is equal to 0, we can find x-intercept. So x-intercept for this one is 1, 0. So the x-intercept here, when y is equal to 0, when y is equal to 0, to the power of 0, which is equal to x plus 1, to the power of 0, which is equal to x plus 1. Therefore, what? It becomes the 1 is equal to x plus 1. So x is equal to 0. So x is equal to 0. Therefore, the x and y intercept is 0, 0. The intercept point is 0, 0 is intercept point. The intercept is this one. The intercept point is this one, 0, 0. Now, what will be, if it is the intercept, what will be when y moves to infinity, when y moves to infinity, x also moves to where? X also moves to infinity. And when y moves to negative infinity, x moves to where? X moves to -1. X moves to -1, which is considered as the vertical asymptote for the required graph. X is equal to -1 will be taken as the vertical asymptote. X is equal to -1 will be taken as a vertical asymptote, and we have obtained the intercept point, and which is a vertical asymptote. So the graph of this logarithmic function looks like this one. It looks like it passes through 0, 0, and it looks like this one. Sorry for the graph. I have not drawn it very perfectly, but just to show that where the graph looks like this one. So what will be the domain and the range of this one? The domain is from -1 to positive infinity. The domain is that one, and the range is all real number. All real number is a range. The range of this graph is all real number. The range of this, so the intercept point 0, 0. So the range of this graph y an element of real number y greater than 0. Which one is true, Namilo? So for that, and the line x is equal to -1 is the vertical asymptote. The line x is equal to -1 is the vertical asymptote. F of 0 is 1, which is false, and it does not have an y-intercept. It has y-intercept because 0, 0 is x and y-intercept. So the true value is the line x is equal to -1 is the vertical asymptote. Okay. Now, which is also the seventh question, the solution set of 2 sine x minus radical 3, which is equal to 0, on the interval 0 to 2 pi. So we have given 2 sine x minus radical 3, which is equal to 0. What will be the solution for this on the interval 0 to 2 pi? So rearranging this one, we have sine x is equal to radical 3 over 2. Sine x is equal to radical 3 over 2. So using hypotenuse triangle, using right angle triangle, using the Pythagoras theorem, if we take this one is angle, sine x is opposite over hypotenuse, so which is this one is radical 3 and this one is 2. So by the principle, the right angle triangle principle, the adjacent square times plus the opposite square gives the hypotenuse square, so that this value becomes 1. This value becomes 1. So what is sine x is equal to the known angle, which gives sine x is equal to 1 over 2. The known angle that gives sine x is equal to 1 over 2. What that degree is 60 degree. That degree is 60 degree. If we want to change to the radian, we can multiply pi over 180 degree. So it becomes what? It becomes pi over 3. So the first angle is pi over 3, which is found between 0 and 2 pi. And the other angle that makes the sine value positive. So we know that in the quadrants, all the trig functions become positive here, and all sine is positive here, and tan is positive here, and cos is positive here. Therefore, this one is found in the first quadrant, and the other positive value will found on the second quadrant. Therefore, if this one is pi over 3, then the coterminal angle to this one, the other angle is this one. The other angle is this one. So it becomes this one is pi over 3. So what's left is this one is 30 degree, and this one is 30 degree, and 30 plus 30, which is 60 degree. So adding pi over 3 itself, pi over 3 plus pi over 3 is 2 pi over 3. So pi over 3 plus pi over 3, we get the other angle, which is equal to 2 pi over 3. So the two zeros or values of x that makes this statement true is pi over 3 and 2 pi over 3. Pi over 3 and 2 pi over 3 is the first choice, clearly. Okay. The next one is about the Cartesian product, the cross product of two sets. If set A has and set B has 2 and 3 elements respectively, then the number of subsets of set A. So A cross B, A cross B, A cross B. We have this one, A cross B. If we have number of A and number of B, then the number of elements in a set A cross B is the number of elements. The number of elements in A cross B is the number of elements. The number of elements in A times the number of elements in B. The number of elements. So this is the number of elements in the Cartesian product, in the cross product of the set A and B. But the question is respect then the number of subsets of the set A, the subsets of so for a given set A, the number of subsets for this set A is to the power of n, assuming that A has n elements, So the number of subsets of this cross product is to the power of 2 times 3, which is just, you can write here, which is 2 times 3. The number of Cartesian elements are 2 times 3, which is 6. Therefore, the number of elements for the number of subsets for the Cartesian product is 2 times 3, which is 6 to the power of 6 is the solution for the subsets of the elements. So the solution for this one is to the power of 6D. Okay, given a function f of x is equal to 3x squared minus 7 and g of x is equal to 2x plus b for constant b, what are the possible values of b so that the function g of f of x crosses the y-axis at 5? Therefore, the first one is f of x is this one and g of x is this one, and the composite function g of f of x which is equal to 3 times 2x plus b, the whole square minus 7 is g of f of x. So what's an intercept? Y-intercept is obtained by making x is equal to 0. Therefore, g of f of 0 by making x which is equal to 0, we obtain that which value is equal to how much? Which is 5. If so, when this value is 0, 3 times b squared minus 7, 3 times b squared minus 7, which is equal to 5. If so, 3 times b squared, which is equal to, rearranging the numbers, you will get 12. So dividing by 3, b squared, which is equal to 4. Therefore, the value of b is squaring both sides. So you'll get plus or minus 2. The value of b is plus or minus 2. The value of b is plus or minus 2 will be the solution. Plus or minus 2 is solution. So from the set of alternative, plus or minus 2 is A, the first question. The next one is find the inverse of a function of x equals 2 over x plus 3. So clearly how to find the inverse of a function. The inverse of a function, it has steps. So the first one is represent y which is equal to just y is equal to 2 over x plus 3. 2 over x plus 3. You will represent just like this one, the first step. The next step is replace x to y to x, and then solve. The next step is solve for y, and then that one is the inverse of the function. So let's replace y by x and x by y. Let's replace y by x and x by y. So which is y plus 3, y plus 3. So implies that solving for y next, let's solve for x now, y now. So it becomes y plus 3 y plus 3 is equal to y plus 3, which is equal to 2 over x, y plus 3, which is equal to 2 over x. So solving for y, you will get y, which is equal to 2 over x, minus 3, 2 over x minus 3. So which is the same as taking x as common. You taking x as common, which is 2 minus 3x, 2 minus 3x, which will be y, which is equal to 2 minus, which is now f inverse of x is this number, this function, which is 2 minus 3x over 3x over 3x over 3x over 3x over x, 3x over x. So what is that this function in the alternative? Is that this function in the alternative? If so, we can see 2 minus 3x is here. 2 minus 3x over x is here. So the alternate from the set of alternatives, C is the inverse of this function. So today, this is enough. Then we will look the next section, the remaining